Welcome, everyone. In this session, we're going to walk through a class overview that covers where the course has come so far, how the support system works, how the website navigation and account approval process functions, and what's planned for upcoming classes. This is a great opportunity to get oriented, whether you're catching up or reviewing what's already been covered. Let's dive in. Let's start with the class overview. The instructor makes an important point here. If you've been absent or are joining late, don't panic. You can go back and look at what was covered, and even if it doesn't fully make sense the first time, that's completely normal. When you come back to the current class, it acts as a revision. You'll have those moments where you think, oh, so that is what that was about. Understanding builds gradually, and the key message is it is perfectly okay if you don't understand everything right away. Now, the instructor is very clear about the support structure. Yes, there is support available, and that's reassuring. But there's also an important caution here. Don't become overly reliant on that support to the point where you stop trying to understand things on your own. The support is a safety net, not a replacement for active learning. And here's something exciting. After this course wraps up, internships are on the horizon. The connections you build during this class don't just disappear. They continue, and that network stays with you. Let's talk about the account approval process, because this is a practical and important workflow. Here's how it works step by step. First, a request is sent from the student's or shop's end. That request triggers an email notification to the admin. The instructor then reviews the request and approves the account. In this case, it was a shop account, referred to as a DoCon account. Once the instructor approves it, they receive a confirmation email. After that confirmation, the instructor is able to log in and access the approved account. It's a clean, email-driven approval chain. Now, let's look at website navigation. During development, the website runs on what's called a local host, meaning it only exists on your own computer and uses a URL like localhost. But once the site goes live, that localhost address gets replaced with a real domain name. The important teaching point here is this. Users need to be shown how to navigate to the shop section. Specifically, they need to type /doken after the website's main address. So whatever the final domain is, users go to that domain, add /doken, and they reach the shop URL. This is something the instructor emphasizes must be taught to users going forward. Once users are approved, they get their own individual login. Here's how that plays out. The instructor approves specific accounts, for example, accounts number 2 and 4 were mentioned. Once approved, those users receive an email. That email contains their login credentials. From that point on, whenever they visit the website and go to the login page, they enter their email and password and they're in. They can check and manage their own account at any time from anywhere. It's a straightforward self-service login system. And as we'll see in the next class, there's also a login with Google option being added to make this even more convenient. Finally, let's look at what's coming up in the next few class sessions. Tomorrow's class will focus on user login, specifically how to implement login with Google. This is a very commonly used feature in modern web applications, so it's an important one to learn. If time permits, the add to cart functionality will also be introduced. The day after tomorrow, more topics will be explored, and there's also an extra class day plan to make sure everything gets covered properly. The instructor also mentions that if there are any errors or bugs that come up, those will be looked at and addressed during class as well. So there's a solid roadmap ahead: login, cart functionality, and error handling. Continuing from where we left off, the instructor notices that the admin panel still has a registration link in the sidebar. Since admin users don't need to self-register, this gets removed to keep the panel clean. The important thing to note here is that this isn't permanent. If registration is needed again later, it can simply be added back. This kind of housekeeping keeps the admin interface focused and uncluttered. Next, the instructor adds a profile edit feature to the admin panel. This is done by adding a profile resource, and once that's in place, a profile menu item appears in the sidebar. Clicking on it takes the admin user to a profile editing page where they can update their information, including changing their password. The instructor then tests the password change functionality. They enter a new password, in this case just 123 for testing, confirm it, and also provide the current password as required. When submitting, there's a slight delay before the two fields appear, but the instructor points out this is simply because the app is running on a local development environment, not a live server. After signing out and signing back in, the password change is confirmed to be working correctly. At this point, the instructor pauses to recap the full flow that has been built so far. A shopkeeper submits a registration request. The admin receives an email notification about this. The admin then goes into the panel and activates the shopkeeper's account. Once activated, the login credentials are sent to the shopkeeper. The shopkeeper can then log in to their own panel. This entire flow is now working end-to-end, and the next step is what happens after the shopkeeper logs in. Once the shopkeeper is logged in, their next task is to enter their products. The instructor explains that the product model already has all the necessary fields, things like name, slug, description, and more, because the database tables were all set up right at the beginning of the project. Now, the focus shifts to building the interface that lets the shopkeeper actually enter that data. To build the product entry interface, the instructor runs the filament make resource command for the product model. Filament then asks a couple of configuration questions. First, what the title attribute should be, and the instructor sets this to name, meaning the product's name field will be used as the display title. Second, it asks which panel to create this resource in, and this is where it gets interesting. The instructor chooses the shopkeeper panel, not the admin panel. This is a really important architectural point. The instructor explains that in a multi-panel filament setup, the admin panel and the shopkeeper panel are completely separate from each other. Each panel has its own authentication system, its own dashboard, and its own set of resources. The code for each panel is entirely independent, so when the instructor adds the product resource to the shopkeeper panel, it only appears there. The admin panel remains unchanged. This separation is what makes multi-tenancy work cleanly in this kind of application. Earlier in the project, when the shopkeeper logged in, their panel was essentially empty, just a dashboard with nothing else. The instructor now explains exactly why. No filament resources had been added to the shopkeeper panel yet. The admin panel had resources like shops and users, but those were only registered in the admin panel's codebase. Now, by creating the product resource specifically for the shopkeeper panel, the shopkeeper's sidebar will start to populate with the tools they actually need. So continuing from where we left off, when a new account is created, the system sends out login credentials, an email address, and a default password. In this example, the default password provided was 480. Now, the important thing to understand here is that this default password is meant to be temporary. The very first thing a user should do after logging in for the first time is change that password. But here's what often happens in practice. The user logs in, forgets to change the password, and moves on. Then the next time they come back, they realize, oh wait, I actually need to change this password. So the system needs to handle that scenario gracefully. Now, when a user needs to change their password, where do they actually go? The process is straightforward. After logging in, the user navigates to their panel, specifically to the profile section. From there, they can find the option to change their password. It's not buried deep in settings. It's accessible right from the profile area. So if you're building or configuring this kind of system, make sure the password change flow is easy to find. Users shouldn't have to hunt for it. Here's a really important concept to understand. There are two completely separate authentication systems at play here. One is the admin panel, and the other is the DoCan panel, which is the store or vendor panel. These are not the same system. They are entirely independent of each other. So when you're setting up password management or any kind of login flow, you need to be clear about which system you're working with. A credential that works for the admin panel does not automatically work for the DoCan store panel. They are distinct, separate systems. So when you're working inside the panel and you see two options, admin and DoCan, how do you decide which one to use? The answer depends entirely on what you're trying to build or manage. If you're working on something that affects the entire platform, like global settings or user management, that belongs in the admin panel. But if you're working on something store-specific, like a vendor's products, their store profile, or store-level resources, that belongs in the DoCan panel. In the example being discussed, the goal is to build something for the store, so DoCan is the correct choice. Now let's talk about how resources are organized in the file structure, because this is where things can get confusing. By default, when you create a resource inside the filament directory, it belongs to the admin panel. That's the default behavior. However, if you want a resource to belong to the DoCan store panel, it needs to be placed inside the DoCan folder within filament. So the rule is simple. If the resource is directly inside the filament resources folder, it's for admin. If it's inside the DoCan subfolder within filament, it's for the store. This folder structure is what determines which panel the resource belongs to. Let's zoom in on the DoCan folder structure specifically. When you navigate into the filament directory and then into the DoCan subfolder, that's where you'll find or create resources that are specific to the store panel. For example, a product resource for managing store products would live here, inside the DoCan folder. This is a deliberate architectural decision. It keeps admin functionality and store functionality cleanly separated. And this pattern extends further. If you were to add a user panel in the future, you'd create a user folder at the same level, and resources inside that folder would belong to the user panel. The folder name determines the panel scope. What's really elegant about this architecture is that it scales. The pattern is consistent. Every panel gets its own folder inside the filament directory, and every resource inside that folder is scoped exclusively to that panel. So right now we have admin at the root level and Docan inside its own subfolder. If the application ever needed a dedicated user panel, say for customers to manage their own accounts, you'd simply create a user folder at the same level as the Docan folder and put user-specific resources inside it. This is the filament multi-panel architecture pattern, and understanding it is fundamental to building well-organized, maintainable applications. Now, with all of that context established, the next practical step is to actually build out the product resource inside the Docan panel. Since this is a store-level resource, it's about managing products that belong to a vendor store. It goes inside the Docan folder. The starting point for any resource like this is a list view. A list is the most fundamental piece. It shows all the products in a table format with columns for things like the product name, price, and status. From there, you can build out the create, edit, and view pages, but the list is always where you start. It gives you the foundation to work from. So, continuing with the product details management, one of the first problems to solve is the shop ID field. When a shop owner is entering a new product, they should never have to manually type in their own shop ID. That would be a security risk, because someone could enter another shop's ID and associate their product with the wrong store. The solution is to auto-populate the shop ID using the currently logged-in user. In Filament, this is done by defining a method called mutate form data before create. Inside this method, the shop ID is injected into the data array using the authenticated user's ID, specifically from the shop guard, which maps directly to the shop model. This way, whatever shop owner is logged in, their ID is automatically attached to every product they create. It's worth pausing here to understand how Laravel guards work, because this is a concept that trips up a lot of developers. When you call auth.user without specifying a guard, Laravel automatically uses the web guard, which is the default. But in a multi-user system like this one, where you have both admins and shop owners, you need to be explicit. If you write auth.guard.shop.user, Laravel looks at the shop provider, which maps to the shop model, not the users table. So the guard tells Laravel which authentication provider to use, and therefore which database table and model to look up. Getting this right is critical when you have multiple types of authenticated users in your application. An important design decision here is that the shop ID should only be set at the time of product creation, not during editing. Think about it. Once a product has been created and belongs to a specific shop, there's no valid reason to move it to a different shop. That would break the data integrity of the system. So the mutate form data before create method handles the creation case, but there's no equivalent mutate form data before edit needed for this field. The shop ID is a one-time assignment. This is a good example of thinking through your business logic carefully when designing your admin panel. Next up is the slug field. A slug is the URL-friendly version of a product name. For example, Nike running shoes becomes Nike-running shoes. Rather than asking the shop owner to type this in manually every time, the system auto-generates it from the product name at creation time. This is done using Laravel's built-in straw.slug helper, which you import from illuminate.support.straw. The slug field itself is hidden on the create form. The user never sees it, but it is visible on the edit form, so if someone wants to customize the slug later, they can. This is a clean user experience, sensible defaults with the flexibility to override when needed. For the product description field, a plain text area is not good enough. Product descriptions often need formatting, headings, bold text, bullet lists, maybe even embedding images. So the plain text area is replaced with a rich editor component. This gives shop owners a proper word processor-like experience when writing their product descriptions. Additionally, the column span is set to full, meaning the description field stretches across the entire width of the form, which makes sense given how much content it might hold. The same full-width treatment is applied to the title field, while price and discount sit side by side in a two-column layout. Product images need special attention. First, the images field is configured to accept multiple files, because a product typically has more than one photo. The image editor option is also enabled, giving users basic cropping and editing tools. But here's a critical point. The storage disk must be set to public, not private. If images are stored in the private disk, the front-end applications simply can't access them. They're hidden from public URLs. To fix this, the disk is switched to public in the file upload configuration. Then you need to run the command php artisan storage link, which creates a symbolic link from the public folder to the storage directory. Without this step, even files in the public disk won't be accessible from the browser. Here's another important data isolation issue. By default, Filament's resource table fetches all records from the database, meaning every shop owner would see every other shop's products. That's obviously a serious problem. To fix this, the getEloquent query method is overridden in the resource. This method lets you customize the base query that Filament uses to fetch records. By adding a where clause filtering on shop ID equal to the currently logged in shop owner's ID, each shop owner now only sees their own products. This is a fundamental multi-tenancy pattern. Every user sees only their own data, even though it all lives in the same database table. On the public-facing homepage, the behavior is different from the admin panel. Here, all products from all shops are shown, because this is what customers browsing the site should see. A products variable is created by querying the product model, ordering by ID in descending order so the newest products appear first, and limiting to 8 results. This data is then passed to the view using Compact. In the Blade template, a for-each loop iterates over the products and renders a product card for each one. The key distinction is the shop-based filtering only applies inside the admin panel, not on the public storefront. The product card is the visual building block of the homepage. Each card displays the product image at the top, with overflow hidden on the container so the image doesn't spill outside its bounds. In the top right corner, a discount badge is shown using absolute positioning, but only if the product's discount is greater than 0. There's no point showing a 0% badge. The product name appears below the image, and the price section shows both the original price and the discounted price in red. The discounted price is calculated dynamically. At the bottom, a View Product link takes the user to the full product detail page. The link passes the product slug in the URL. The discount calculation is straightforward math. The discounted price equals the original price minus the discount amount. The discount amount is calculated by multiplying the original price by the discount percentage, then dividing by 100. So if a product costs $100 and has a 39% discount, the discount amount is $39, and the final price is $61. In the Blade template, this is written as product price minus, in brackets, product discount times product price divided by 100. This entire discounted price block is wrapped in a conditional. It only renders if the discount is greater than 0. If a product has no discount, only the regular price is shown. To build the product detail page, a route is defined that accepts a slug parameter, so the URL looks like /product/Nike running shoes. This route points to a product method in the page controller. Inside that method, the slug from the URL is used to find the matching product in the database using a where clause. If no product is found with that slug, the abort 404 function is called, which displays a standard page not found error. If the product does exist, its data is passed to the product detail view. Using slugs instead of numeric IDs in URLs is a best practice. It's more readable for users and better for search engine optimization. When passing the product data to the detail view, there's an important consideration around the images field. Because multiple images are stored as a JSON array in the database, Laravel needs to know to cast this column as a PHP array when it reads it. This is done in the product model using the casts property, setting images to array. Without this cast, the images field comes back as a raw JSON string, and trying to access it like an array in the Blade template will cause an error. Once the cast is in place, you can access individual images using array index notation. For example, product images index 0 gives you the first image. This is a common gotcha when working with JSON columns in Laravel. The navigation bar is updated to include meaningful links for the storefront. The products link goes to a page that shows all products from all shops. The deals link is more interesting. It filters the product list to only show items that have a discount greater than 0. This is a simple but effective way to create a dedicated sales section without needing a separate database table. A link to register a new shop is also added, which is useful for attracting new vendors. The categories link is removed since that feature isn't implemented in this project. Each of these pages follows the same pattern: a route, a controller method that fetches the right data, and a Blade view that renders the product cards in a loop. There was a bug in the shop approval email system. Every time the shop record was saved, even for unrelated changes like updating the shop name, an approval email was being sent. The root cause was that the condition only checked whether the current status was approved, but it didn't check whether the status had actually changed. The fix involves comparing the old status with the new status. The old status is retrieved from this.record.status, which gives you the value currently stored in the database before the save. The new status comes from the incoming data array. Only if these two values are different and the new status is approved should the email be sent. This is a classic before and after comparison pattern for detecting field changes. To bring it all together, here's the multi-tenancy picture. Each shop owner, when logged into the admin panel, only sees their own products. This is enforced at 2 levels. First, when creating a product, the shop ID is automatically set to the logged-in owner's ID. They can't assign it to someone else. Second, when listing products, the query is filtered so only records belonging to that shop owner are returned. Meanwhile, on the public-facing storefront, all products from all shops are visible to any visitor. That's the whole point of a marketplace. The three key technical mechanisms making this work are mutate form data before create for auto-setting the shop ID, get Eloquent query for filtering the list view, and auth.guard shop.user.id for identifying who is currently logged in. At this point in the debugging process, the author identifies a specific type of error that keeps appearing and traces it back to redundant JSON decode lines scattered across the codebase. The fix is straightforward. Find every place where JSON decoding is being called unnecessarily and simply remove those lines. The author uses Ctrl+F to search through the code and locates these decode calls in multiple places, including inside the product section. Each of those lines gets removed one by one until the error clears. One of the most practical debugging habits shown here is using the search function, Ctrl+F, to find every occurrence of a problematic pattern across the entire project. In this case, the author searches for the JSON decode call and finds it not just in one file, but also in the products file and the links pagination area. This is a great reminder that when you introduce a bug or a redundant line in one place, it often gets copy-pasted or replicated elsewhere. Always search globally, not just locally. As the author continues debugging, they notice that the links pagination for the products page hasn't actually been implemented yet. There's a line around line 202 and beyond that references this pagination, and since the feature doesn't exist yet, that line can simply be removed. The author also notes that if this had been routed through the controller properly, the issue would have been more obvious and easier to understand. This is a good lesson. Always route data through the appropriate controller layer so that errors are easier to trace. After cleaning up the decode errors, the author moves on to testing the actual filter functionality. They set a minimum price of 8,000 and a maximum price of 13,000 to see whether the filter works correctly. An important observation here is that at this stage, the filtering is happening purely on the JavaScript side. The backend is not yet involved. This means the filter is client-side only, which is fine for initial testing, but will need backend integration for a complete production-ready solution. During testing, a console error appears. After investigation, the author traces it to an audio icon element in the UI. The fix is simple. Remove the audio icon and the console error goes away. There's no need to touch the backend for this particular issue. This is a good example of how sometimes a console error that looks alarming is actually caused by something as minor as a UI element that doesn't have a valid source or handler attached to it. Always check the console carefully and trace errors to their actual source before assuming it's a complex backend problem. Here's a practical insight the author shares. The filter fields are already present and visible in the UI. So rather than designing the filter logic from scratch or second-guessing the structure, you simply write your code to match what's already there. The UI is your specification. If the filter panel shows certain fields, your JavaScript and backend logic should align with those exact fields. This saves time and avoids inconsistencies between the front end and backend. The author acknowledges that the current implementation is intentionally kept simple. It's a working prototype, not a finished product. But they point out that with a bit more design effort, the same functionality can look significantly more polished and professional. This is a common pattern in development. Get it working first, then make it beautiful. The foundation is solid. The design layer is what can be improved with more time and attention. One filter that appears in the design is the category filter. But the author is clear that this hasn't been built yet. The category feature simply doesn't exist in the backend at this point. So the guidance here is skip the category filter in your logic for now, but keep it in the design. This way, the UI looks complete and future-ready, and when the category feature is eventually built, you just wire it up to the existing design element. Don't remove it from the UI just because the backend isn't ready yet. The author also touches on related products, specifically where the JSON data for related products is coming from. The related products JSON is already present in the API response. The key is knowing where to find it and how to use it correctly in the front end. This is a reminder to always inspect your API response structure carefully before writing rendering logic. The data you need is often already there. You just need to map it correctly. So let's bring it all together. When you encounter this type of error, redundant JSON decode calls, console errors from stray UI elements, or filter logic that doesn't match the UI, the process is the same every time. First, you search to find every instance of the problem across all your files. Second, remove the redundant lines cleanly. Third, trace console errors carefully. They're often caused by something small, like a missing icon source. And finally, when a feature isn't built yet, stick it in your logic, but keep it in your design so you're ready to wire it up later. The author's message is clear. Once you've seen this type of error and worked through it, you'll know exactly how to handle it the next time.